In Chapter 10, we'll take a look at food production and the environment. The core case study for Chapter 10 is super interesting. It is about an urban food oasis. So read the story about a former basketball player, Will Allen, and his company Growing Power Incorporated, which is an ecologically based farm powered by solar electricity and hot water systems that grow organic vegetables and herbs. On the farm are also organically raised chickens, turkeys, goats, fish, and honeybees. So how does this farm use the principles of sustainability? In section 10.1, we'll talk about what is food security and why is it difficult to attain. Well, in less developed countries, people suffer from health problems associated with not getting enough to eat, while in more developed countries, others suffer health problems from having too much to eat. Factors influencing food supply include poverty, war, bad weather, climate change, and effects of industrial food production. Poverty is the root cause of food insecurity. Scientists project that by 2050, we will need to feed at least 9.9 billion people, almost half of which live in poverty and experience food insecurity. So how do we feed more people without seriously harming the environment? Many people suffer from chronic hunger and malnutrition and don't get enough vitamins and minerals. Take a look at Figure 10.2. The poor cannot afford to eat meat and survive by eating lower on the food chain. 20,000 kilocalories of grains provide 2,000 kilocalories each for 10 people, while 20,000 kilocalories of grains provide enough food for a beef steer to provide 2,000 kilocalories for just one person. Let's take a closer look at chronic hunger and malnutrition, and we'll start with a few basic definitions. Chronic undernutrition or hunger is a reference to not enough food to meet basic energy needs, while chronic malnutrition is a reference to not enough protein and other key nutrients. In low-income, less developed countries, diets center on high carbohydrate grains, and there's very little protein in the diet. Remember Figure 10.2 that we just discussed. Now, food deserts, where there's no access to fresh food, happen even in developed countries. In these regions, diets tend to be high in fat, sugar, salt, and there tends to be little protein in the diet. Take a look at the hunger map from 2019 that is on your screen. Remember, there are health problems associated with too much food. Overnutrition is when food energy intake exceeds energy use and causes excess body fat. It lowers life expectancy, it increases susceptibility to disease and illness, and it lowers productivity and life quality. According to the CDC in 2015, many living in the United States are overweight or obese. 72% of adults over the age of 20, while 33% of all children fell into these categories in 2015. I encourage you to check out a great site, choosemyplate.gov. It is there to guide you to make wise decisions in your diet. There's even an app that you can download, and it's really, really cool. Let's talk about how food is produced. Today, agriculture uses both high-input industrialized and lower-input traditional methods to produce the world's food supply. Food production has increased dramatically. 3 systems supply most of the world's food: croplands of rice, wheat, and corn; rangelands, pastures, and feedlots, meat and meat products; fisheries and agriculture, which include fish and shellfish. Half of the world's people survive on rice, wheat, and corn, which violates the biodiversity principle of sustainability. Take a look at Figure 10.6. Growth of worldwide grain production shown on the left of wheat, corn, and rice, and per capita grain production shown on the right between 1950 and 2016 are illustrated. Do some critical thinking. Why do you think per capita grain production has grown less consistently than total grain production? three major advances have led to staggering increases in global food production, and that includes irrigation, which is artificial mixed methods that supply water to crops, synthetic fertilizers, and synthetic pesticides. Those are the three big advances that have led to these increases in global food production. Let's compare industrial and traditional crop production. We'll start with industrial or high input agriculture. It involves heavy equipment, fossil fuel, commercial fertilizer and pesticides, and a lot of money. It also involves monocultures, which is growing 1 to 2 crops. This makes the food supply vulnerable to disease. Now let's talk about traditional crop production. It is low input agriculture. It centers on solar energy and human labor to grow a crop that will feed a family with no surplus. It also entails polycultures, growing several crops. Organic agriculture, or crops grown without the use of synthetic pesticides and inorganic fertilizers or genetic engineering. The Green Revolution centered on monocultures of selectively bred crops. It used large amounts of water, synthetic fertilizers, and pesticides. Soil erosion, desertification, irrigation, water shortages, air and water pollution, climate change, and loss of biodiversity may limit future food production. Let's take a closer look. Large inputs of energy are needed to grow, store, process, package, transport, refrigerate, and cook plants and animals. In the United States, 10 units of fossil fuel energy are needed to produce 1 unit of food energy. Fishing fleets use 12.5 units of energy to produce 1 unit of energy from seafood. Industrialized food production is dependent on fossil fuel, resulting in a net energy loss. Take a look at Figure 10.10. World seafood production, including both wild catch and aquaculture, grew between 1950 and 2014. With the wild catch generally leveling off since 1996 and aquaculture production rising sharply since 1990. Producing food has major environmental impacts. While industrialized agriculture has allowed farmers to use less land to produce more food, it is environmentally and economically unsustainable. Industrial agriculture removes 70% of fresh water from surface sources and aquifers. It uses 38% of the world's ice-free land. It emits 25% of all greenhouse gas emissions, and it produces 60% of all water pollution. Soil erosion can result from the movement of soil from one place to another by nature and by human activity. Flowing water, the largest cause of soil erosion, carries away soil loosened by rainfall. Wind loosens and blows away topsoil particles from flat land and dry climates. Farming, deforestation, and overgrazing expose land and hasten soil erosion. Take a look at Figure 10.12. Flowing water from rainfall is the leading cause of topsoil erosion, as seen on this farm in the U.S. state of Tennessee on the left. Severe water erosion can become gully erosion, which has damaged this cropland in western Iowa, shown on the right. Desertification is the process in which the productive potential of topsoil falls by 10% or more. It is a major threat to food security. It decreases soil productivity, and desertification can be moderate, 10 to 25% drop in productivity, severe, a drop of 25 to 50%, or very severe, drop of more than 50%. Agricultural activities have serious environmental consequences. For example, irrigation can boost or lower a farm's productivity. 20% of the world's irrigated cropland produces about 40% of the world's food. Irrigation water has a variety of salts, which can lead to soil salinization. Livestock production generates 18% of all greenhouse gas, and fertilizer use releases nitrous oxide increasing atmospheric temperatures. Take a look at Figure 10.15. White alkaline salts have displaced crops that once grew on this heavily irrigated land in the U.S. state of Colorado. Clearing and burning forest leads to the loss of natural biodiversity. Deforestation in the Amazon basin and clearing of grasslands for cattle ranching and plantation farming decrease biodiversity. As fewer varieties of plant and animal species are used in farming, agrobiodiversity decreases. Using a mix of cultivation techniques, biological pest controls, and selective chemical pesticides as a last resort will enable farmers to sharply decrease pesticide use without decreasing crop yields. Remember, natural enemies control the populations of most pest species. This free ecosystem service is an important part of Earth's natural capital. Humans upset the checks and balances of natural pest control when we clear forest and grasslands, plant monoculture crops, and use synthetic chemicals to kill pests. Pesticide usage is regulated by the EPA, the USDA, and the FDA under the Federal Insecticide, Fungicide, and Rodenticide Act. Unfortunately, adequate funding has not been provided for effective management and enforcement of this legislation. Efficient resource use, reducing the harmful effects of industrialized food production, and eliminating government subsidies will help us produce food more sustainably. Take a look at Figure 10.24. The figure illustrates some soil conservation methods, such as A. terracing, B. contour planting and strip cropping, C. alley cropping, and D. windbreaks between crop fields. So how can we shift to more sustainable food production? Well, we can eat less meat, no meat, or organically certified meat. We can choose sustainably produced herbivorous fish. We can buy certified organic food, eat locally grown food, compost food waste, and cut food waste. Reducing poverty and malnutrition, producing food more sustainably, and relying on locally sourced food will improve food security. Let me know if you have any questions.